We're asked to convert the following to logarithmic form. It's actually not difficult. I'm going to show you how is it. Why is it not difficult? So if you look at question A, right, you're given 2 to the power of 7 is 128, right? So if you're going to convert this index form to log, of course you need to have a log first, right? So you write log first. Then you go back to your index form and identify the base. So 2, this is your base. Right, so a log will need to have a base. Every log will need to have a base, right? So in this case here, this will be log base 2. All right, so once you have done that, the next thing is we have to fill in the rest of the numbers, right? So the 128 will go after your log base 2, and then your power, this is your power, or your index, your exponent will become your answer. Okay, it's not difficult. Let's look at B. Right, so first of all, we need to have a log. Right, so let's identify the base. So the base obviously is 10. 10 is your base here. So the base in your index form will be the base in the log. Okay, so you identify that first. Right, and after that, the answer, the value you get for 10 to the power of negative 3, this answer here, okay, you fill it after your log base 10. And then the answer will be your power of the index form, which is negative 3. Okay, let's look at part C here. Right, so that's right now log, identify the base, which is E. Okay, the answer is 54.6, and then the power is 4. All right, it's a bit tricky here. Why tricky? Because log base E, right, log base E has a special name. Log base E is actually called the log base E is actually the natural log. Natural log, okay, natural. And the letter to represent the natural log is Ln. So log base E, right? All right, you can write it as Ln. Okay, so from here you can simplify it to be Ln, then 54.6 equals to 4. Okay, your log base E simplified into Ln. Ln is a natural log. Other questions, and these questions are the questions that I've taken from worksheet 20, right? So when they give you the hard copy for worksheet 20, do remember to fill in the blanks with the discussions we've done here. All right, so in this part 2, we need to convert the following to index form. So what we did earlier on was given the index form, and then we convert to log. Now it's the other way around. Okay, but it's not difficult also. Why is it not difficult? Because the simple rule that we go by is to identify the base. The base is very important. Okay, once you identify the base, then the rest is quite easy. So if you look at this example here, the base of your log is 4. The base of your log is 4. So we start off with the base. Always start off with the base, right? And then the power will be your answer, and that gives you equals to 64. Okay, so it's not difficult. Let's try B. All right, this one is a bit tricky. Why a bit tricky? Because the previous slide we learned natural log. There's another type of log called the common log. All right, common log. Why is it called common log? Because it can be found in almost every calculator. So common log, the symbol for common log is actually log base 10. Okay, common log is log base 10. Right, log base 10. And usually, right, they represent log base 10 as LG. All right, they represent log base 10 as LG. Okay, right. So if you were given the questions LG, then right, you should be able to change it to log base 10. You need to know what to change to lah. That means LG is log base 10. Okay, right. So after you have done that, identify the base. The base is 10. So we start off with the base. So 10 to the power of negative 3 will give you 0.01. Right, pretty easy, yeah? Okay, now let's look at the next one. All right, so in the earlier slide, we learned that Ln, okay, let's recap. Ln, it's called the natural log. So Ln is log base E. All right, log base E is Ln. So what we need to do is we need to convert your Ln to log base E. So the base here will be E. So E to the power of Q equals to 5. Okay, so to summarize, you need to know what is a common log. Common log, it's log base 10. Right. Most of the time, you're just represented by Lg. Natural log is log base E. Most of the time, it's represented by Ln. So after learning how to convert from log to index and index to log, there are 4 very important logarithmic laws that we need to learn. So we're going to do the product law first. We're going to prove the product law, meaning we're going to prove log mn base a can be simplified into log m base a plus log n base a. Right, so the first step, we're going to let a to the power of x equals to m. So why do I let a to the power of x? Because if you look at what you're supposed to prove, right, the base here, it's base a. Can you see it's base a, base a? Therefore, the first step is I'm going to let a to the power of x equals to m. Why m? Because you're given m and n in the product law there. Then the second one is we're going to let a to the power of y equals to n. All right, so what we're going to do, we're going to convert it into your logarithmic form. Right, so you start, remember what we have always been saying, identify the base. Base is a here, then a will be the base for your log. Then m will be your the one besides your log base a, and then the power will become your answer. Likewise, for your a to the power y equals to n, convert it into log form. Right, so we're going to label the equations. And then I'm going to take equations 1 times 2. That means if you take the left hand side, which is a to the power of x, you multiply with a to the power of y. And the right hand side will be m times n. Okay, here you apply what we have learned early on, that if you have the same base, what you do with the power, you add them, right? That is what you learn in the rules of indices. And then what's the next thing we do? Remember is always converting from index to log and log to index. So now we are given the index, we're going to convert it to log. So if you look at what we have here, the base is a. So obviously we need to have a log base a. All right. And what exactly is x? X is the one that the one in purple, right? The one that written in purple color. X is actually log m base a. So we're going to replace x with log m base a. And then your y, replace it with log n base a. So we have proved the product. We have proved the product law. All right. So to give you an example of how you can use the product law. So if you have that, say log a 63, let's say. All right. So 63, you can actually simplify it into 9 times 7. 9 times 7 is 63, right? And from there, I can actually simplify it further into log base a9, then plus log base a7. Okay, you can also 63 can also be, you can write 63 as 21 times 3. 21 times 3 is it? Yeah. Then that will gives you log base a21 plus log base a3. Alright, the next law we're going to learn is the quotient law. Okay, remember there are 4 laws that we need to learn. So we have learned product law. The next one is the quotient law. Right, so quotient law is just that, okay, the product law means m times n. So quotient is just m over n. So if you have m over n, you can simplify into log m base a, then minus log n base a. We're going to prove that. So again, you start off with the same, what we've done earlier on, let a to the power of x to be m. then a to the power of y to be n, convert it into log form, which you should be good now. You should be good. You should be good at it now. Right. And then we're going to take equation 1 divide by equation 2. And then you apply what you have learned in the rules of the indices. If it's a to the power of x divided by a to the power of y, right, you can actually combine them into a to the power of x minus y. And then the next thing, of course, is to convert it to logarithmic form, log base a. Okay, and then you get the answer. So what it means here is that, let's have an example. Let's say if you have log base a, all right, 3 divided by 10. Okay, so you can actually further simplify it as log base a3 minus log base a10. Or the other way around is if you are given log base a2 minus log base a3, then you can combine them into log base a2 divided by 3. Okay, this is what it means. The third law we need to learn is the power law. Okay, so let's recap. We have learned the product law, quotient law. The next one is the power law. Why is it power law? Because it deals with the n. Can you see it's x to the power n? That's power there, right? So if you have x to the power n, you can actually bring the n, and put it in front of your log x base a. So how do you get this law? So first thing first, we're going to let it's a bit the what do you call it, derivation is a bit different from what we have done for product and quotient. We start off by letting log x base a equals to m. Why you let log x base a equals to m? Basically because you're proving log x to the power of n base a. Right, so that's why I use log x base a. So we let it equals to m. So what's the next step? The next step is to convert what? Because you start off with log, so we convert to index form. You see, earlier on is we start off with index, convert to log. So now you have log, convert to index form. So the base is a, right? Okay, the next step is that I'm going to multiply both sides with the power n. Right, so that will give me a to the power mn equals to x to the power n. Okay, so we convert from log to index and then multiply both sides, raise both sides to the power n. And the next step is we're going to convert the index to log. Okay, but what actually, okay, mn, I'm going to write it as nm because I'm going to substitute m with whatever that I let it earlier on. I let m to be log x base a, right? So I'm going to replace your x. Yeah, we're going to replace your x, your m with log x base a. And that is our power law. So to give an example, to give you an example how to use the power law, that means if you have, let's say, 2 log base 3, if you have 2 log, if you have 2 log 3 base a, you can use the power law to give you log base a 3 to the power of 2, and that gives you log base a 9. Or likewise, if you have log base a 4 to the power of 3, you can actually bring the 3 to the front of your log base a4. That's how you use the power law. Right, there's something very, very, very important when you use the power law. Okay, you see, in the first example, right, the n just belong to your y, the power n belongs to the y only. Okay, so you cannot just simply bring the n to the front to put it in front of your log base a. Right, you can only do it, all right, look at it very carefully, you can only do it when you have bracket your xy. So in this case here, then the n is the power for both xy. Right, then in this case here, then you can use the power law. Here can use the power law, can apply the power law. Right here you cannot. Okay, right, so what you need to do is if you want to apply the power law in the first case, right, Okay, I'm going to teach you how to do that. If you want to apply the power law in the first case, then we will have to use product law first. You have to use product law to separate them first. So that will give us log base a x then plus log base a y to the power n. Okay, can you see that? Then you can apply power law for the second one. Log base ax, you can't do anything, just leave it alone. In the second one, can you see now that the n belongs to y, so you can actually bring the power n down. Okay, so that's how you can apply the power law in the first example. So we're going to learn how to derive the change of base, because the base that in your calculator, what you're given is common log. Common log is base 10. But what happens if you need to find log base, let's say log base 2, let's say find log 3 base 2 or log 4 base 5, the kind of thing, then you can't really use a calculator, right? So what happened is that we need to learn how to we need to learn how to change whatever base that we are given, like base 2, base 3, base 4. How do we change it to base 10 so that we can use the calculator to help us evaluate the answer, right? So if you look at how the change of base, the rule looks like, all right, if you're given log base a, and if you want to change it to log base b, can you see from one single log will be equals to a fraction, and then the numerator will be log base b x, and then the denominator will be log base b, and the original base, you see the original base, look, this is your original base, right? What comes to here. Okay, so let me give you an example, a numerical example. Let's say if you have log base 3, 4, all right, you're going to change it to log base 2, right? You want to change it to log base 2, so you need a fraction, and then of course you need a log on top, not on top, sorry, wrong words to use. You need the log at the numerator and also a log at the denominator, and every log need to have a base, right? So just now we say we want base 2, right? So we put in our base 2 first. Okay, so what goes to the numerator will be your letter 4, then your original base 3 goes to your denominator. Okay, this is how we do it. Now we're going to do the proof. Right, so I'm going to let's start off with log base ax, then it equals to y. So if we start off with log and then logarithmic form, then we're going to convert it to index form. So here my base is a, so convert to index form will be a to the power y equals to x. All right, so what we need to do here, the next step is I'm going to introduce log base b. Yeah, because I want to change my log base a to log base b ma. So I'm going to introduce log base b on both sides. So this is what I'll get now. Okay, and then from here what I need to do is, can you see that I can actually apply the power law? Why? So basically because I let log x base a equals to y, so actually I'm finding the formula for y. I'm finding the formula for y, so I need to make y the subject. So from there I can actually apply the power law, bring my y down, put it in front of a log a base b. Okay, I'm going to make y the subject. All right. Okay, so what actually is y? Y is the substituted values for log base ax. So if you put everything, if you not put everything wrong, if you put your substituted value back into your y, which is log x base a, so can you see we actually have successfully derived the formula on how we change base. So this is actually a much easier derivation than your power law. I think of all the four laws, this one is the easiest to prove. Before we do the questions given, let's write down all the laws that we have learned so far. Right, so basically there are four laws. The first one is your product law. Right, second one is your quotient law. Okay, sometimes okay, I'm going to write it a reverse way, because you also need to know the reverse. It's not always like if you have log xy base a, sometimes they may give you log x base a plus log y base a, then you should be able to use the product law to combine them into log xy base a. Right, so if you're given log x base a minus log y base a, then you can combine them into log a, then x over y. And if you are given this power law, not given, sorry, remember this power law we have learned? All right, y to power b, you can actually bring down the power, put it in front of your log. And of course, it's a change of base. Let's say if currently you have base a, you want to change it to base c, let's say. So you need to have a fraction, write down the log first, write down the base c that you want. Then your b will be at the numerator, original base will be at the denominator. Okay, let's look at 1a. There are two ways of doing it because it's just log 4 base 2. Some of you may like to let log base 2 4 equals to x. Alright, and then you convert it into index form. Here the base is 2, so always start with the base. So the base is 2, so 2 to the power x equals to 4. And then you can rewrite 4 as 2 to the power of 2. So therefore x equals to 2. So therefore log base 2 4 is equals to 2. So this is rather a rather long way of doing it. You can do that, of course, since we are given just a single log, right? But a shorter way, of course, is to apply what we have learned. All right, so how do we apply what we have learned? So log base 2, so 4 is actually 2 times 2, isn't it? 2 times 2, so you can actually simplify them into log 2 base 2 plus log 2 base 2. And log 2 base 2 is 1. Okay, we have learned earlier on. We've learned earlier on that log a base a is 1. So log 2 base 2 is 1. Okay, earlier on we've learned that log a base a is 1. So log 2 base 2 is 1, so 1 plus 1 equals to 2. Alright, this is the second way. A third way, it's even easier. That is, you actually write 4 as 2 to the power of 2. 4 is 2 to the power of 2, right? Then you can apply the power law, bring the 2 and put it in front of your log 2 base 2. And log 2 base 2 is 1, so 2 times 1 equals to 2. So there are three different ways of doing it. I let you choose which way you want. I may not want to use the first way, but it's still fine. It's all right if you because you're dealing with single log. Okay, you're dealing with single log, so you can do it that way. Right. All right. Let's look at part B. Okay, again, I'm going to show you several ways of doing it. Not several, just two ways of doing it. First one, I can actually write 10 as 10 to the power negative 1, right? And then I can use the power law. So in this way here, I'm using the power law. Let me write it down. I'm using power law. Okay, so we're just bring the negative 1 to the front. Okay, I think a lot of you likes to write it this way. Wait, wrong. Okay, right. So negative 1 times log base 10 is just negative log base 10, 10. All right, don't really have to write. If you want to write negative 1, then it would be good to put the multiplication sign there. Right, because you can't have negative 1 and another, you know, the log, the letter L looks a bit like 1. So it looks like negative 1, 1, that kind of thing. Doesn't it look a bit strange? So if you want to put a negative 1, make the put in the multiplication sign. If not, it's just negative log 10 base 10. So log 10 base 10 is 1, so you get negative 1. Okay, that's the first way. Second way, of course, is we can apply your quotient law. So that will give us log 10 1 minus log base 10 10. Okay, Right. So we learned several things earlier on. We learned that log base A is 1, right? We also learned that log base A1 is 0. Right. So log 1 base 10 will be 0. Log 10 base 10 is 1. So 0 minus 1 is negative 1. That is the second way. Of course, the third way, which some of you may want to change it to index notation. Okay, that's fine also. Because I keep saying because you're dealing with single log, so it's okay if you want to do it that way. Right, let's look at part C. So for part C, you wouldn't want to change it individual log to index form. Can you imagine how messy, yeah, how messy, sorry, how messy it will be if you're going to let this equals to x, and then you find the values of x, let this equals to y, find the values for y, let's equals to z, find the values for z, and then you combine the three of them. So I would never encourage you to do that, okay? So I'm not going to show that messy way to you. So then which way do I encourage you to do? Of course, is to apply the laws that we have learned. Okay, your product law. So whatever you have learned, try to apply them. You have to learn like to use the laws, what's the word used, interchangeably. Okay, sometimes you use this, sometimes you use that. Then how are you able to know when you use what? That is, you need to have a lot of practice lah. You need to practice doing questions after questions, then you will build up your confidence and you know what method to use. So we can apply product law here. That will give you log 3, then 4 times 2 gives you 8. Right, and then this one you can use a quotient law because they're all base 3. So 8 divided by 72, that will gives you 1 over 9, is it? Yeah, I think so. 1 over 9, 9 times 8, 72. Yeah, all right. So from there, you can apply your quotient law again. Oh, okay, if you don't want to apply quotient law again, right, you can write 1 over 9 is 1 over 3 squared. And then that will gives you 3 to the power negative 2. And then you can just apply your power law, bring the negative 2 down. Okay, it really appears very easy, you know. If you just listen to my explanation, right, you just like that. Right, but you honestly need to practice doing it. Then you can actually appreciate the laws. All right, let's look at part D. So again, part D, I will not encourage you to go and convert that to index, convert that to index, combine. No, don't do that. Okay, you only do that when you have a single log. So can you see that you have base 6 here, base 6 here, and this is a negative? All right, but if you do like that for me, it will be wrong. Let me show you what some kids may do. Sorry, not kids, some students may do, and that is they just happily take 54 divided by 3. Okay, and that will be that wrong. Why wrong? Why wrong? Okay, observe very carefully here. I have a 2 that's in front of a log 3 base 6. I cannot just ignore the 2, right? 2 is it's like a friend. How can you just ignore your friend? So therefore, what is therefore? Therefore, this guy, I need to do something first. That means I need to apply the power law here first. Okay, so that's why you need to know your laws very well at the fingertips. So I'm going to bring the 2 up to give me log base 6, 3 to the power 2. Bracket it, I think. So 3 squared will be 9. And here, then I can apply my quotient law. My goodness, 54 divided by 6, that is what? 6, 6 times, yeah. So log 6 base 6 will be 1. Okay? So after doing questions 1, I think you would have more confidence now to do question 2. Right. So question 2A. So I'm going to go through at thunder speed. I know I'm just joking. Right, so look at question 2a. 2a is similar to, I think 1c, is it? 1c? That you need to deal with this, you have to apply power law first, deal with the best friend, there's a number 2 there, right? So I need to deal with that guy first. Okay, we need to bring it up to your 4. Okay, and that I will get 4 squared will be 16. Then can you see this is a minus sign there, a subtraction sign, apply quotient law. 8 over 6 will be half. And half, you can write half means 1 over 2 to the power 1. So you can write it as a negative index. Okay, and then again apply power law. See how, what do you call that? Power law, how fantastic it is. Right. Oh, so that will be your answer. Yes, because it says express as a single log. So that's a single log. Single log means there's only one log there. That's what you mean by single log. All right, let's look at part B. Okay, now you should be able to be very confident, ready to use power law. Okay, power law, power law. So that gives you 5 to the power of 2 to the power of 3. Okay, so let's give you log x 25 minus, oh, sorry, this is base x. If it's not base x, then I cannot go any more further. 8. All right, so I can apply quotient law here. And then I can apply product law. Oh, we have not done product law for so long. Mostly it's quotient and, okay, right. So that will give us log base x 25 over 2. You can write it as log base x 12.5. Or if you want, you can just leave it as 25 over 2. Alright, with all the confidence built up after solving 1a, b, c, d, and 2a and 2b, right, we should be able to do 2c without having much difficulty. Right, LG, if you were to recall, LG is log base 10, it's common log. But I don't think there's any necessity, or it is not necessary to change LG to log base 10. We should leave it as LG. Okay, we can apply power law here, also power law here. So let's do it. All right, I want to bring to your attention to something very important. What is it that's very important? All right, if you look at bracket 3 over 2 to the power of 4, what this means is 3 over 2. That means you actually, the whole thing 3 over 2 is the power of 4. It means 3 over 2 times 3 over 2 times 3 over 2 times another 3 over 2 4 times. Right, but if you don't put a bracket there and we just put 3 to the power of 4 over 2, what it's saying is it's just that this number 3, you multiply itself 4 times. Right, can you see the difference? Right, so brackets, you must know when to use it appropriately. Okay, so let's continue. Here we can apply the quotient law because the operation here is a negative. So they're all log to base 10, same log. Same base. So this will be divided by bracket 3/5 and then the square bracket. You can use the calculator. All right, just use the calculator to work this out. Right, if you want to use mental calculations, then it will be 8 over 75, then divide by 3 squared will be 9, 5 squared will be 25. Then you flip your change your division sign to multiplication, flip your 9 over 25 into 25 over 9, and that will gives you 5 times 5, 5 times 1, 5 times 5, oh, 3. That will gives you 3. 8 over 27. That will give you 8 over 27. I think it's easier just to use a calculator lah. Alright, this one here, we can apply the product law. So I'm going to erase off this part here. Okay, the product law here, which means it will give you log then 8 over 25 times bracket 3 over 2 to the power 4. Alright, again you can easily use the calculator to manipulate the answer, or if you wish to practice your mental calculation, then just go ahead. That gives you log 3 over 2. Okay, right. Yeah, very good. Congratulations to all of us for coming so far. Let's do question 2D. That will be the last question for this lessons on logarithmic functions. Alright, that's a very useful tips that I would like to share with you. If you're given any numbers like 2, 3, 4, okay, you can always rewrite it as 2 times 1, 3 times 1, and 4 times 1. Then depending on what base that you need for the specific log, let's say if you need log base 3, alright, you can actually write 2 as 2 times log 3 base 3, because recall that we learned log a base a is 1, right? So likewise, okay, if you want the log base 5, can you see how useful it is? Okay, so 2, because I'm having a log base 3 here, so I'm going to write 2 as 2 times log base 3, 3. Okay, and I can apply the power law to bring our 2 to the power 3. And that gives us 3 squared, that will be 9. Here we can apply the product law. That gives us log 3, 9 times 5, that is 45. So log 45 base 3. Actually, that's not the end yet. We still have one more questions on change of base. So brace up. Okay. Don't give up. So this question is on change of base. Change of base. Okay, let's do a recap. Supposing you have log base A, alright, and you want to change it to log base B. So we have a fraction, then write down the log first. So every log must have a base. So if you want it base B, just put a little b there. Be careful of the way you present your log. The base is basically smaller in size compared to the other letters. X will be at the numerator, the original base A will be at the denominator. Okay, let's look at part 1. Right, let's look at the questions given, blah blah blah, express each of the following in terms of P and Q. In other words, your answer that you need to, the questions require you of is, the answer will be something like 2P, 3P, or P over 4, that kind of thing, or P plus Q, that kind of thing, okay, in terms of P and Q. Okay, so if you look at the questions, do you realize that what you're given, the one that are given to you are all in base 2. You practically don't have one that is in base 7. So what are you going to do? Yeah, don't cry. We can apply this change of base. So what base do I want? Of course, base 2 lah, because you're given base 2, right? So let's write the fraction first. Write your log. Okay, what base you want? Base 2. Put the little 2 there. So what is the numerator? 6. Okay, 6 is the one that goes at the numerator. The original base 7 will be at the denominator. Okay, so what do we have here? So you're given log 6 base 2 is P, right? So we can just substitute log 6 base 2 as P. And you're given log 7 base 2 as Q, right? So you can put that. See how simple it is? Alright, let's look at part 2. Log 442. Okay, log 442. Right. So again, change it to log base 2. Okay, so this questions here a bit tricky. Why a bit tricky? Because you're only given log base 2 6 and log base 2 7. You're not given log base 2 42, right? So what are you going to do? So 40, you can break 42 into its factors. 1 times 42, 2 times 21, 3 times oh, I'm not very good at mental calculation. 3 times 14, 6 times 7. So which one would you use? Of course, you use 6 times 7, isn't it? Why? Because these are the one given in the questions. Right, so 42, you can simplify it into 6 times 7. Then how about 4? Right, we have done this in questions 1a. You can rewrite 4 as 2 squared. Okay, so look at the numerator. Which rule can you use? Which law? Sorry, which law? There are basically 4 laws, right? Product, quotient, power, change of base. Yes, we can use, let's count to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, you're right. We use product law. Very good. Good job, good job. Use product law. Then how about the denominator? Which law do I use? Let's count to 10 again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, you're right. Power law. Very good. You're very good. Okay. What's the next step? You can substitute log 6 base 2 to be P, log 7 base 2 to be Q, and what's the denominator? What is log 2 base 2? Let's count to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, you're very good. Log 2 base 2 is 1. So 2 times 1 give you 2. So that complete the lessons on logarithmic functions. Please learn it well. Right, thank you.